Want to welcome you to summer 2026 semester. Uh, I think I'm going to do some kind of introduction, and after that, I'm actually going to hear from you. I will also need you to introduce yourself, being the first class. You just tell me your name and what you majoring in. So I think I'm going to start with that, and after that, I'm going to say something about myself. Then we're going to go into the lecture proper. But let me start by knowing you first. Okay? Yep.
Hi, I'm Bee. I'm a graduate student in material science engineering.
Thanks for coming. Thank you so much. Okay.
I'm Cameron. I'm majoring in mathematics with a focus in financial.
Thank you for sharing that.
Yeah, I'm majoring in data science.
Thank you.
I'm majoring in math.
Thank you for sharing that. Thank you for sharing that.
Majoring in data science.
Thank you.
Majoring in economics.
Thank you.
My name's Adi. I'm majoring in econ and math.
Thank you so much.
Majoring in economics and statistics.
Thank you for sharing that.
Majoring in stats.
Thank you.
My name's Andrew. I'm majoring in chemical engineering and data science.
Thank you for sharing that.
I'm majoring in statistics.
Thank you so much.
I'm also majoring in statistics.
Thank you. Thank you.
My major is economics.
Thank you.
It's Morgan, and my major is computer science.
Thank you for sharing that.
I'm majoring in data science.
Thank you.
I'm Tyler, and I'm majoring in data science.
Thank you for sharing that.
Corinne, and I'm majoring in math.
Thank you for sharing that.
My name is Ibrahim, and I'm majoring in computer science.
Thank you for sharing that. I think somebody just walking. Yeah.
Statistics.
Thank you for sharing that. Okay, so my name is Kazim. I had a PhD in mathematical statistics from University of Ibadan, Nigeria. Has anybody heard about a country called Nigeria? Okay, thank you so much. So I had my PhD in 2016, and in 2015, I had opportunity of presenting my work at the University of Oxford in England, and I started teaching at this level in 2012. I started from University of Ibadan, Nigeria. So I joined the services of the School of Statistics, University of Minnesota in 2018. I think I'm 8 years into my appointment here. I'm also an assistant director of undergraduate studies. I have 5 girls. My wife and I, we've been busy statistically. So, my first, let me see, just 1 second. Yep, my first daughter just graduated from Winona State University, studied nursing. My second daughter just finished her high school. She's going to be attending this university in the next fall. So my third daughter is going to be a sophomore. My fourth is going to be a 7th grader, and Wendy, the last, is going to be a 6th grader. And this is my beautiful wife. Okay, so that's my family. About this course. This course is called Theory of Statistics. Let me tell you this. We don't just do what we do. There's a reason why we do what we do. Those at the back, can you hear me? If you are having trouble time getting the way I talk, or you don't hear me at all, please let me know, okay? I just want to make sure everybody get the information. Now, we don't just do what we do. We got a reason why we do what we do. I'm actually going to tell you the essence and significance of you taking statistical theory. So why is that necessary? I'm actually going to discuss that before we start the course. That's my area of research. I'm into robust statistical modeling and statistical machine learning. Now, I want to believe a good number of you have access to the course Canvas, right? Okay. From time to time, there's going to be information, that I'm actually going to be disseminating. I will advise that you keep track of that. We live in a world by information. Does that make sense? Okay, so the office hour is actually published on Canvas, among other information. This particular class, the original venue supposed to be 212, mechanical engineering. Or I got information that they actually putting that in shape. So probably by next week, we're going to return to the original venue. Now, this is the material for this course, and I published the electronic version online on Canvas. So in case you do not have a physical textbook, so make sure you download that. So this is already published on Canvas. Okay. Of course, I'm actually going to be posting my lecture materials ahead of time. Of course, what I'm going to walk you through this week, I think I've already published all of them. Who have seen that? You've seen that? Okay. Ahead of lecture. Of course, there will be lecture materials published ahead of time to give you opportunity to see what we want to discuss. Of course, we're going to have assignment, and there will be solution provided at the end of the day. And to the best of my knowledge, there's going to be discussion. There's going to be lab discussion, where discussion is going to take place. So more information about that will be disseminated. I promised to have 6 assignments, but you know what? It's only only 5 that will count towards the final grade. Initially, I was proposing 2 midterms, but I think I just put it down to 1. We're only going to have 1 midterm and 1 final exam. But let me explain the midterm. And I need every one of you to pay attention. I'm going to explain the modality around the midterm. You can still put June 26th to June 28th. And I'm going to explain why I did that. The midterm is actually, I'm going to post the midterm on June 26th. But you're only going to have, it is only when you're ready that you're going to log on to the Zoom to take the exam. The exam is going to be left open for so many hours, but your time is going to be running out because it's been programmed. Maybe I'm going to program that for maybe 60 minutes or 75 minutes. I'm still going to decide on that, which means for the midterm, you can start at any time you want to start. But except that by June 28th, you're never going to have access to that anymore. So I'm going to tell you the time it's going to be posted. Of course, on June 28th, 11:59 p.m. in the night, you're not going to have access to that anymore. So which means the midterm is not going to be written in person. You're going to write midterm online, on Zoom. You all need to log on to Zoom when you want to write it. Even though you can log on to Zoom in the middle of the night, I may not be on the Zoom with you, but it's being recorded. You are being recorded. You're going to log on with your video on. Does that make sense? You log on to the Zoom with your video on. In the middle of the exam, if you want to go to the bathroom, if you want to use the bathroom, you need to write in the chats that you want to go and use the bathroom. So I'm tracking the environment, wherever environment you're going to be, writing the exam. So I'm going to say this one more time. The midterm will be posted on June 26th. And of course, you're not going to have access by 11:59 p.m. June 28th. which means you have like 2 days to complete that. But you know what? You don't have access to that for the entire 2 days. You're only going to have, the moment you click, when you are ready, you click on start, your time is going to be running out. Does that make sense? Any question on that? Is there any question on that? Okay, if there's no question on that, there's going to be final. The final exam is going to be written in this class. I mean, in 212. I'm actually you're going to know ahead of time, but it's going to be done in person. The final exam will be done in person. I award extra credits. You know, when students answer my question correctly in class, I award extra credit. And you know what? You can be accumulating your extra credit point, and you wait until the final exam. Then you can send me a message on how you want to spend it. You can say, okay, I want to spend my extra credit on assignment, or you want to spend your extra credit on exam. So it's your extra credit. So I'm actually going to listen to you on how you want to spend it. Does that make sense? So because I believe class participation matters. Okay? So that's my belief. So the final exam, July 31st, 9 to 11 a.m. Okay? Then I will be reading in person. So which means in all, we're going to have 2 exams. 1 midterm and 1 final. Does that make sense? And we're going to have 6 assignments. Okay? But only 5 assignments will count towards your grade. I will automatically drop assignment with the one you have the lowest grade. Or you can decide on your own, just want to do 5 assignments. But I will advise you do 6, so that you're going to have, opportunity, So, okay. Group discussion is okay. Allow that. Okay. But make sure your submission is actually unique as far as exam is concerned. No late work, except in real emergencies. When I say real emergencies, of course, it could be medical or something else. Okay? And you need to write me ahead of time so that I will take that into consideration. And in case somebody is attending a conference, of course, you need to let me know. So like I said about assignment, only 5 out of 6 is actually, that I'm actually going to use at the end of the day. Okay, so before exams, I normally release practice questions so that you're going to have opportunity to know the areas the exam will cover. And I normally go over the practice question with students in class. Okay, I'm going to tell you what the expectation is. I allow cheat sheet, 2 pages of cheat sheet. Okay, where you can write notes, you can write formula, and whatever you want to write. So 2 pages of cheat sheet, either in the final or in the midterm. Of course, I allow scientific calculator. Okay, not a graphic one. Scientific calculator, not a graphic one. Okay, and of course the exam is closed book. And let me say this. I need you to be honest, from time to time. The summer semester is very, very short. Somebody can get stuck. That's okay. But reach out when you get stuck. Okay, I want to make sure I carry everybody's along. But problem disclosed is problem solved. You can actually count on me. And you can whatever you discuss with me will be treated with absolute degree of confidentiality. So when you get stuck, because you pay for the service, you need to be served better. So if you get stuck or you don't understand what is going on, reach out. Is there any question at this time? Any question? Everybody is hearing me clearly, right? If you have a trouble time understanding the way I talk, please let me know. Okay, so I'm actually 1 second. I'm gonna stop my share now. I'm gonna go into the course. So, like I said, I've already materials, the lecture materials for the week already assigned. So if I were you, you can go over the material. Okay. Now I want to go into the course. I need you to pay attention. Okay. You know what? If what we want to do now, what we want to start is mathematical. But you know what? We don't just do math. We got a reason why we do math. I'll four of us provide you explanation about the reason why we want to do what we want to do now. Is everybody ready? You're all ready, right? Before I'm going to start, if you want to get here in my class, I think you need to be, you need to pay attention when you are in class. And because the summer semester is very short, I advise you to come to class regularly. Is that a deal, right? Okay. Now, we want to start right now. But you know what? We don't just do what we do. We got a reason why we do what we do. Why do you need theory of statistics? I remember the other time when I was asking you to introduce yourself. You actually came from different departments, different courses. But why do you find yourself here doing theory of statistics? I'm actually going to explain. Because what I'm showcasing now is just topics in the theory of statistics. But why do you need the theory of statistics in the first place? And I need every one of you to pay attention. I'm going to go historical, okay, for you to be able to see a connection between the reason why you are here and what you're learning. We live in a world where there's variations. You know, when I say variations, the fact that you actually come from different departments, that's a variations. You didn't come from the same departments. And look at the kind of cloth you're putting on right now. It's not the same. The varieties of cloth around make this place colorful, make this place beautiful. Now, we got variations in the world. Different things happen in different days. At times in business, we record profits. At times in business, we record loss. At times in life generally, we are happy. At times we're sad. You know, my daughters ask a lot of questions. Why are we sad? Why can't we be happy all the time? But my response is, I don't know why. But I know we live in a world that's a mixture of up and down. Even though what I want all the time is happiness. But it's part of life. Now, I need you to pay attention. We actually find ourselves in a world where there's variation. That's number one. As human beings, we want to understand the world. We want to be in charge. We want to take control of what is going to happen. We don't just want something happen and just happen without us knowing about it. So which means, as human beings, we want to understand the world, we want to understand our environment. You know, when I say our environment, what do I mean by that? The environment could be medical. I want to know what is going on in medical environment. I want to know what is going on in political environment. I want to know what is going on in economic environments. I want to know what is going on in business environment. I want to know what is going on in the environment generally. But you know what? When you look into the environment has a lot of variations. And whenever there is variations, you need probability knowledge. Because probability thrives in variation. If there's no variation, there's no probability. Now, we want to understand the world, right? So which means to be able to understand the world, what do we need? We need knowledge. That's why you are here. You want to understand the world. You need knowledge. Okay? Where will the knowledge come from? Okay? The knowledge is going to come from somewhere. The knowledge is going to come from information. Okay? The knowledge is going to come from information you got. Right? But where will the information come from? Information is going to come from data. Please pay attention. Information is going to come from data, which means we need to collect data. If I want to answer a question, if I want to understand my environment, whether medical, whether political environment, any environment at all, I need to collect data. But let me tell you this. When you have data set are figures. They are just numbers. Okay? Now, when you have your data set, you do not have information immediately. I'm going to say that again. The moment you get your data set, you do not have access to information immediately. Something needs to be done to data for you to have access to the information hidden in the data. I'm going to say that again. Don't forget, you need knowledge, right? Knowledge comes from information. Information will come from data. But when you get your data, you don't have access to information immediately. Something needs to be done to data for you to access the information. Now, what do we need to do to data to access information is this guy, model. Okay? And you know what we want to do in theory of statistics? The theory of statistics will provide mathematical foundations for the models. Okay, we need models. Okay, now let me tell you what, model is going to come in form of an equation, in form of notations, in form of symbols. Okay, now we're going to use the model, we're going to apply the model to the data. Okay, why we apply the model to data? We want to bring out the hidden information in the data. Okay, and so if I'm going to define a model now, please pay attention. If I'm going to define a model now, model is a mathematical or statistical representation of reality. We want to understand reality. We want to understand the physical world. We want to understand our environment. And you know what? We're actually going to use model to depict reality. Okay, when you are subjecting model to data to access information in the data, then you are using model to depict reality. Okay, but let me tell you this. Model is not the same as reality. Model is not the same as reality. But you know what model is going to do? Model will give us, an approximate reality. Okay? You know why model can be reality? Because we can never have an exact characterization of reality. That's not possible. There's always going to be error. So in this course, you're going to hear us talking about errors. We can't do without making errors. We acknowledge that. And the reason why there's always going to be error, because model does not give us exact reality. The model even though we use model to depict reality, Model will only give an approximate reality. And that was why George Boss, you know what George Boss said? He said, all models are wrong, but some are useful. All models are wrong, but some are useful. Do you know why he said that? If you ask a question about how truth a model is, if you mean a whole truth, the model is not completely true. Does that make sense? So I'm just trying to prepare your mind. Okay, now you understand the story now. We're going to be focusing on models. But do you know what theory of statistics is going to talk about? The theory of statistics, okay, will enable us to know how statistical models are formulated. The theoretical reason behind models don't just appear suddenly, they were developed. Okay, and the principle, the underlying principle of putting a model in place. A model is like a method. How do we arrive at a model from the first principle? How do we develop it? How do we come about them? That's what we call theory of statistics. So the theory of statistics will provide what I call some, the basic foundations of underlying models, the models that we use in an uncertainty world to take decision. We all want to take decision. We can't take decision without, applying models, to data. And don't forget, the information that we need is hidden in the data. Without models, there's no way we'll be able to extract the meaningful information that we need. Do you understand the story? Now we want to start now. I just explained to you, by theory of statistics, we're trying to look, we want to study ways through which, data is actually transformed into knowledge. How data is transformed into knowledge. Okay, transformed into knowledge that will enable us to take a very good decision that we want, that will enable us to make prediction, okay, and we're able to do that under uncertainty, and we do that across field, whether in medicine or in engineering or in business or in politics and so on like that. Does that make sense? Now, let's get started. I've given you the background. Let me tell you this. I understand my maths and statistics perfectly. You know why? Because I pay attention to notations. I pay attention to stories behind every equation. Then I was able to relate to real life. Now, I want to start now. Okay, I want you to pay attention to stories behind every notations. Students in math, students in statistics, they have issue with star, they have issue with math because of the fact that they have issue with notations. They don't pay attention to stories behind every notation. So I want you to follow me, and whatever we're going to be doing, relate that to real life. Because we don't just do what we do. We have reason why we do what we do. Are you ready to all start now? Now let's start this topic. Probability on a finite sample spaces. That is where we're going to start from. When I say probability on a finite sample spaces, what do I mean? Now, let's take a look at this. Has anybody heard about sample space before? Anybody? Thank you so much. If you want to study, if you really want to get information, okay, there's something you need to have in mind. Possibility. Oh, a businessman or woman, we need to have possibility in mind. What are the possibilities? Oh, I could make profit or loss or break even. Those are possibilities. Then we call that sample space. So when I talk about sample space, I'm trying to talk about collection of possible events. Okay? Collection of possible events. Now, when I say finite sample space, okay, now the finite actually means, the word finite actually means the number of events that I have in that sample space can be counted. I can also have infinite. But this course, this particular topic, we're going to be focusing on finite. Okay? Now, we want to perform probability on a finite sample space. Now, I want you to take a look at this. When I say sample space, it means I have different events. Okay? Now, if I have different events, that's a variations. I talk about variations, right? Now, if I have different events, if I have variations, then I can think about probability. Without variations, I can't talk about probability. Probability, okay, probability thrives in variations. If there is no variations, there's no probability. There's no mathematics. There is nothing we can manipulate in this world. There's no economics. There's no data science. There's no politics. There is no medicine. There is nothing without variations. But because there's variation in medicine, there's variation in data science, there's variation in politics, there's variation in business, that we need a knowledge of probability. Why do you think we're considering probability here? Because the probability will enable us to measure uncertainty. Will enable us to quantify uncertainty. Okay, now let's take a look at this. In the outline, I'm going to talk about set theory. Because we're going to be talking about set. When I say set, oh my God, I can only use set if there's variations. Okay? When I say set, because sets contain elements that can be distinguished from one another. Then I need a theory. Okay? For me to be able to understand maybe the reason why variation occur, or maybe to be able to make a decision. Okay? Then I'm also going to talk about function of a random variable. Then we'll talk about examples. Then I'm going to talk about probability models. I talked about models the other time. That the models that we're going to be using will be probabilistic model. Okay? Okay. Now, let's get started. If you really want to understand the world, you need to first understand that there's variations, right? And the very first thing you should be thinking about is sets. Okay? So what do I mean by sets? Just pay attention. Set is a collection of objects. These objects, they can be distinguished from one another. You have a set of days. You have events in business. You have events in medical line. You have events in economies. Okay? Different events. Okay? So we can actually refer to that as sets, which means if I want to understand what is going on in economy, if I want to understand what's going on in medicine and so on like that, where variation occur, then with the knowledge of sets, then I will be able to get going. Now, please pay attention. In this course, we're going to be using some notations. Where you are supposed to use an uppercase, don't use a lowercase. Where you are supposed to use a lowercase letter, don't use an uppercase. I want to walk you through now. Now, when we're talking about sets, okay, when we're talking about sets, we're actually going to use an uppercase. Take a look at this guy. Do you see that X, this guy? Can somebody see that? This guy? Oh, give me 1 second. Let me do this. Are you seeing this? Can you see that guy? That's an uppercase. That's a set. Right? But you know what? What about this guy? That's a lowercase. The lowercase is talking about the elements. Element inside a set. The element inside a set, we're going to actually use a lowercase for them, while set itself, we use an uppercase. Does that make sense? Do you know when you write this for me in assignment, you are wrong. When you write this for me in assignment, you're wrong. Because you're telling me that is not going to be an uppercase. That is going to be a lowercase because it's an element. Now, what does this guy mean? Okay, let's pay attention. If I'm talking about this sign, you know what that means? It means from. It's trying to say S is from that. Does that make sense? Please, if you don't understand, please ask me a question. You know, math is probability is difficult to some students because of notation. Go ahead.
If a mistake like that, and say you say an uppercase letter is a set of an uppercase letter, would you lose points for that?
Yeah, like if you define it. Yeah, if you define it, I'm fine. But we have a general acceptable terminology when I'm referring to okay, between Minnesota and United States, which one is bigger? United States, right? So I'm going to use a lowercase for Minnesota, then I'm going to use an uppercase for United States. Does that make sense? Okay, so now this particular sign, it means, you know, you can call it several names. You can actually say from, oh, Minnesota is from United States. Okay, or you can say nice. Okay, so that's what it means. Okay, now I'm actually want to move right now. Take a look at this. Do you see that? I'm having two uppercase. Please pay attention. I'm having two uppercase. Situation where I'm having two uppercase, the two of them are set, but one is bigger than the other. Does that make sense? Now, A is a set. This guy is also a set. But you know the sign in the middle means belongs. A belongs to X. Even though A has some element, I can refer to A as Minnesota. Minnesota has people, right? United States also has people. Okay, but you know what? Minnesota belongs to the United States. So these two, they are upper cases because the two of them are sets. But in this case, here, where I have a lowercase is not a set but an element within a set. Does that make sense to everyone? If you don't understand, ask question. Okay, now I'm moving now. I'm gonna move right now. Okay, so if you take a look at what I have, this is an example of set. It could be set of numbers. It could be set of alphabet. It could even be combination. Okay, and another thing. Look at another thing. We can have a set within a set. Take a look at this guy. Please pay attention. Can you see this guy? That's a set on its own. A set inside another set. And if this guy is a set itself, these are just elements. The other ones are just elements. But the fact that I'm putting this inside that kind of parenthesis, I'm trying to tell the world that's a set on its own. Any question? Any question? If you don't understand, ask me question. You pay for the service. Okay? Now I'm moving now. Now we have what we call an empty set. Okay? We have what we call an empty set. Take a look at this guy. That's a notation. That's another notation. You know, we play with notation a lot in theory of statistics. You know, when I say an empty set, who was the first person to get here today? The first person, the first student to get into this class today? Okay. The first person to get into this class met the class empty. Before we started having elements, the set has to be empty first. Does that make sense? Now, an empty set is a set that does without element, nothing in it. Okay, I'm going to create an empty set now. Who doesn't want to pass this class? Who doesn't want to pass this class? That's an empty set. I just created an empty set right now. Take a look at that. So an empty set doesn't have elements. And if there's no element, there's no event, then the probability associated with it will be 0. Does that make sense? Okay. Now I'm moving. Now, do you know that we have different kind of classification when it comes to sets? Some set of numbers are called natural numbers. Some are called integers. Some are called real numbers. Okay? We just wanted to take note of that. We take a look at this guy now. That's a natural number. When I say natural number doesn't include 0. Can somebody see 0? I can see 0 cookie. I can only see 1 cookie, 2 cookies, 3 cookies. Can somebody see -3 cookies? I can see that. So when I talk about natural numbers, then I'm talking about 1, 2, 3, 4, and so on like that. Then we have integers, negative integers, positive integers. Then we have real numbers. When we talk about real numbers, we're talking about all numbers in this world. All numbers in this world that can happen to us. At times, my account may be negative. At times, I may have $0 in my account. And at times, I could have some thousands of dollars in my account. Okay, now let's talk about how we define sets. We have a listing approach and we have a builder notation. Please pay attention. You know, if I'm talking about listing, okay, I actually want to define set, and maybe I say set S. Okay, maybe I say set S is 1, 2, 3, 4, 5, 6, maybe until I get to 100. This is listing. We call that listing. That's listing method. Okay, but how can we actually use a builder notation? Like if I want to use a formula approach, do you know here I can just say X and say S such that, okay, and S is a natural, it's a natural number. S lies in natural number, okay, and I can actually do this. 100. Look at that. You know what that guy is telling me? From 1 to 100. I do not necessarily need to list them out. Okay? So now I need you to see, which we call the builder notation. Okay? So if you take a look at that, where I'm going to say S lies in that with some condition. I can give you an example. Now, take a look at this. 1 second. If you take a look at what I have here now, okay, please pay attention. We want to say a story now. You know what that means? S lies in real number, but it should be greater than 0. Because when I say, if I don't, here, I'm trying to say I need non-negative numbers. Because if I don't put that condition, the real numbers, is made up of all numbers, positive, negative, and 0. Okay? But right now, I'm actually telling the world S lies in real number such that S is greater than 0. So I don't want negative. That's what that guy means. I do not want negative. Does that make sense? Okay. Which means I'm talking about set of positive real numbers. If I wanted to include 0, I can do this. Can you see that? If I wanted to include 0, maybe it's 0 and positive, then I'm going to include that. But if I don't want it to include 0, then I'm not going to include that. Go ahead.
So the left side before the colon defines the set,
Exactly. The left side defines the set.
and then the right side puts restrictions on.
It's a restriction on it. It's just like I'm saying, it's from United States of America, but Minnesota. Minnesota. So I've restricted. Does that make sense? Okay. You know, when I relate my math, I understand my math. And that's why I wanted to try to relate your math. Okay. Now moving. Gonna move right now. Okay, now I want us to take a look at this. When we are focusing on numbers, okay, there's always going to be boundary. Oh my God, Minnesota has a boundary, right? At times when you are driving in Minnesota, driving, you just find yourself in Wisconsin. You can't drive in Minnesota forever because there's going to be boundaries, right? Even United States has a boundary. Every country has a boundary. Okay? That's why they have map. So if you are focusing on a variable x, if you are focusing on values, then you're going to have a boundary. And that's what we're going to call intervals. Okay? Now let's talk about different type of intervals that we have. Now I need you to say the first one. Okay? When it is open and closed, take a look at this. You know that sign means open and open. Open at both ends. Open at both ends. We're going to say S like a real number, but S can be greater than A, but less than B. When we are talking about open and open situation, the X value does not include the extreme values. It does not include A. It does not include B. A and B not included. Does that make sense? A and B not included, but what is included is something between, numbers between A and B. If you go to the next one, close and close. Close and close. When it is close and close, you only including equality. Now, including equality, you are still taking numbers from real numbers, but you are trying to say, I'm including A and B. That's why they are close at both ends. We can have situation where it is open at this end and close at this end, or close at this end, or open at this end. Please pay attention. This course is easy. You can score A easily. I just need you to pay attention. Take a look at this. Open at A, but close at B. When it is open at A, it does not include A. When it is close at a number, it includes that number. Does that make sense? And that's why you see this. Look at that. Where do you see the equality sign? You see the equality sign on B because it is close at B. When it is open at a number, it doesn't include the number. Let's take a look at the next one. Take a look at this. Close at A, open at B. Take a look at that. Now, these are the kind of intervals that we have. Now, let me tell you this. Before you can successfully make a decision under uncertainty, not just decision, a valid decision, you need to be able to understand the boundaries of your random variable X. The boundary can't take forever. So under which boundaries? It's just like in law. Has anybody heard about territorial jurisdiction in law? A court is not going to entertain a case if a court doesn't have a territorial jurisdiction. That's the same thing we're doing here. Okay, now I think I'm going to stop here. We're going to use this material again tomorrow. We just have an introductory class today. In my first class, I normally do this. I need you to rate your understanding of today's topic. Now, you're going to rate from 0 to 100%. If you understand perfectly, put 100% in the email. If you understand, let's say you did not really understand, okay, put in the message what you don't understand. Then I'm going to reply, okay? So do that. I'm going to be expecting your email. Of course, you all have my emails, right? Okay, that's all I got. Make sure you all stay safe and have a lovely day. Bye for now, everyone.